In this video, I'll be describing the results of tests that I've done on what I call the Linear Ferrite Balun. I've conducted a range of additional tests to explore the characteristics of the Linear Ferrite Balun. The first test I'm going to describe is what happens if you don't have any ferrites at all. What happens if there's just a single coax cable? Well, naturally there's no balance, and in theory that should be seen as a perfect circle on my DIY vector network analyzer. In practice, not quite a circle, but certainly the VNA shows that without ferrites there is no balun. So the conclusion was that connecting coax directly to a balanced antenna will not work well at all. The next test I did was just looking at, well, what if there's only one ferrite? How does that work? So one ferrite is significantly better than no ferrites, but still performs poorly. And the solution to that is simply to add more ferrites, which is what I've done. One of the results I've seen in all of the tests of the Linear Ferrite Balun is a persistent remnant imbalance. So I've explored simple remedies to try and improve specifically the voltage imbalance, which has always been about 5%. Previous tests indicate that the imbalance is attributed to the ferrite properties and not to the physical structural construction of the balun itself. The imbalance appears as a 5% amplitude mismatch on the center coax wire. So I tried adding a resistive T attenuator at the antenna end, which in this case is the scope end of the balun. That didn't work. Even with that, I still saw a 5% imbalance on the oscilloscope. And I believe that's because this balun is a current driven device. So any current that goes down the core has to come back along the shield. Any attempt to disrupt that current affects the whole performance of the balun, and the 5% imbalance in voltage amplitude remains there. I then tried adding some very small ferrites on the center wire to reduce the amplitude. These small ferrites actually reduced the amplitude by 20%, but made no difference to the 5% imbalance between the center core and the shield currents. So again, the imbalance appears to be a physical attribute of the ferrite cores and not of the physical structure. This test also showed that the balun is extremely resistant to any attempt to make it imbalanced. No matter what you do, it successfully attempts to maintain the balance with that 5% imbalance. I also tried using 50 ohm terminators. On all of the tests, I've used 100 ohm terminators on the inputs of the oscilloscope. This is because on the balance side, these 100 ohm terminators appear as two 100 ohm loads to earth in parallel, which means that the total impedance seen is 50 ohms. So you need 100 ohm impedance terminators to see a 50 ohm load from the signal generator. Changing the terminators from 100 ohms to 50 ohms had no effect on the imbalance. The tests that I've done are not exhaustive. There's plenty of more options that could be tested, and in this particular case the 5% imbalance is not material for this antenna in this application. There's a lot of other things that I could have tested for. I could have tested other methods for correcting the 5% imbalance that I've seen in the voltage amplitude, but I haven't done that. One of the features that I wanted to include on this antenna was a bar or a tube to mount the antenna on, and this works out to be a really convenient form factor for mounting because the tube can support the antenna at a distance from the tripod. It can house the Linear Ferrite Balun, and it can keep the connecting coax cable away from the antenna. I looked at a range of options around phenolic tubing, fiberglass and plastic tubing, but they're either expensive or difficult to get, or both. Steel tube is cheap and easier to attain. So I did experiments to determine what effect placing a steel tube over the balun would have, and the results are simply no difference. The initial test was with the steel tube floating. It was not grounded or connected to anything. Typically metalwork is not left floating, So I grounded the tube at the unbalanced end, and again that made no difference. I tested the frequency response at 1 MHz, 5 MHz and 50 MHz. 1 MHz is well below the bandwidth that is usable out of the balun, but I wanted to see if the metal affected the signal due to eddy currents and so on. No difference. 5 MHz is at the bottom end of the frequency response of the balun, and again I didn't see any difference at all with or without the steel tube, grounded or floating. 50 megahertz is a normal frequency of operation. It's well inside the bandwidth of the balun, and again the steel tube made no difference whatsoever. So the balun is highly tolerant to how it's mounted. It isn't affected by nearby steel, metal, and it provides a lot of options for mounting. In this case in a steel tube, but it could be without, and it would still work the same. So the conclusions that I've drawn from all these additional tests is that the linear ferrite balun really tries hard to maintain balanced, but the cost of that is a 5% voltage amplitude imbalance, and it's proven to be resistant to any attempts to actually remove that residual imbalance. The linear ferrite balun is impervious to load mismatch and load imbalance. It has a very wide bandwidth, and the lower 3 dB frequency limit is dependent on the length of the ferrites. So the more ferrites you have, the lower frequency limit. The upper 3 dB frequency limit is beyond what I can measure, possibly 500 megahertz or more, probably dependent on the ferrite properties. Good features are that it has a near zero insertion loss. It's got a very wide bandwidth and a flat frequency response. It's tolerant to external circuitry mismatch and highly tolerant to the physical construction. It's simple to build and it doesn't really matter how you make it. There's no interwinding capacitance, so effectively there's nothing to limit the upper frequency limit beyond the properties of the ferrite. The only really bad thing is that it has this persistent residual imbalance, and there's probably a way of getting rid of that, but I just haven't found it yet, and I'm not going to look. So overall, the linear ferrite balun is ideal for this application in its form factor, which is convenient to mount, it's easy to build, and it's extremely tolerant to anything else around it.